Hey, and welcome to this video on the question, what is the future of AI in hospitals? To answer this question, I'll discuss with you a new framework that promises to really unlock the value of AI in healthcare and in hospitals in particular. And after we're done with the theory, we'll actually be building a simple version of this system ourselves, and you will see that the future of AI in hospitals has already begun. As health data scientists, most of you are probably aware that AI promises to impact virtually every aspect of a hospital. A recent paper on the role of AI in hospitals and clinics identified 5 key areas of application. First, there's clinical decision making, then imaging diagnostics, patient monitoring, operations management, and virtual care.
But there is a big problem with all of this, and it's preventing all these applications and AI models to really provide great value. And the problem is that they're all separated. They all live in their own separate silos. They don't share context and they don't coordinate, and so they produce fragmented insights, and each model knows only its narrow domain, and they can't feed their findings to other models. If, for example, a radiology model spots like a tiny lung abnormality, then a follow-up CT should be booked automatically. I mean, if the clinicians have to chase that CT down by hand, then there's actually been no efficiency gain whatsoever. Or just another example, what good is a billing AI if it cannot discuss a case with the AI that was doing the medical documentation? Or how can a digital nurse help the patient if it doesn't know exactly how the patient's surgery went? There are endless examples like this, and the current way of connecting different systems with API integration just falls completely short of solving this problem. A traditional point-to-point interface only lets the AI models or tools exchange very specific structured data. So every time you add or update a component, you also have to update the rest of the entire system. And this really doesn't work for the fast evolving AI. And more importantly, all the processes in a hospital are way too complex and variable to hard code them all like this, one by one. And you might think, let's just build one giant model with all the information, or just have one big shared database. But both is like a huge catastrophic privacy risk if one of these systems would be compromised. And I mean, I wouldn't want the model that sends me the bill to know about my psychiatric history, and I wouldn't want my doctor model to know my billing information. Also, one big model would create an algorithmic monoculture, so it would be prone to the same blind spots and biases across every task. This recent paper, just published last month in April 2025, from very prominent researchers, introduces a framework that aims to solve all these problems. And the solution is MASH.
Actually, not that kind of mesh, but rather multi-agent systems for healthcare. A system of many autonomous AI agents, all connected, communicating, and each specialized for specific tasks, all decentralized, trained on different data, and with access to different tools. But before we get ahead of ourselves here, I think to really understand this, we have to start at the basics and talk about what an AI agent actually is. So, what even is an AI agent? A recent paper by the AI company Anthropic defines agents as systems where large language models dynamically direct their own processes and tool usage and maintain control over how they accomplish tasks. They explain that the basic building block of an agent is an augmented, improved LLM with access to tools, long-term memory, and retrieval of information from external sources. A review paper from January 2025 proposes a framework to define LLM-based AI agents. They say an agent needs 3 things: a brain, perception, and action. The brain module controls and undertakes basic tasks like memorizing, reasoning, or planning. The perception module perceives and processes multimodal information from the external environment. And then the action module uses tools and interacts with that environment. So, back to multi-agent systems, like the MASH. A recent review paper on large language model-based multi-agent systems describes them as decentralized yet coordinated networks of specialized AI agents. So it's basically an entire collaborative ecosystem of AI agents, and each agent is powered by an LLM and is specialized for specific clinical or operational tasks. And each agent is potentially connected to every single other agent in the network. So rather than operating in isolation or with like brittle point-to-point APIs, these agents, they communicate in natural language with each other, just like us humans would. This has many key advantages. Models are doing real-time sharing of insights. They ask for the information they need from other models, or they dynamically hand off tasks to other models, or they even work together on tasks. It's very much like us humans would work in an organization. And this leads to quote-unquote collective intelligence, where there's either cooperative interaction between the agents, or there can even be adversarial interactions between the agents, so like debates. And potentially then these agents can control each other's work and raise concerns if they think something is going on. And this makes the system quite resilient to errors. Also, as we already talked about, this avoids algorithmic monoculture. Another great thing is that these AI agents do all of that in human language, so they maintain human readable logs. And this is great because we can then more easily integrate that into the existing workflows that are obviously all based in human language. And we can also control what they're doing and understand why maybe something went wrong. Another huge advantage of these kinds of systems are scalability and modularity. That means you can plug in new agents or plug out old agents without any re-engineering. This means the system can super easily and rapidly adapt to new needs you might have, or new technologies, or new processes. Also, the decentralization is really great for privacy. Each agent can train on and access only its relevant data silo. And if they need additional data for a task, for example, it can request that specific instance of the data from other modules, or it can just hand off the work to the appropriate model. Either way, it doesn't have access to everybody's health data. The paper gives some great examples of how a mesh would work in practice. Here, several AI agents talk about reviewing pathology slides. The general practitioner agent sends them to the pathologist agent. And after clarifying what these biopsies were of, it then classifies the pathology images as a poorly differentiated carcinoma. The precision medicine agent then enters the conversation and asks the pathologist to also send it to genetic testing. One more example on scheduling an appointment for a breast cancer surgery. The insurance advisor agent approves the diagnosis, and the GP agent asks the care coordinator agent, who then asks the surgery scheduler agent to schedule a surgery. As there is no time slot available, the GP reprioritizes the case and asks the others to monitor if there are any cancellations. And when there actually is a cancellation, the surgery scheduler immediately gets back to them. So these are just some simple examples, but you can see how a system like that would completely revolutionize how a hospital functions. It would truly create an all-intelligent hospital with ever-present AI agents all around it. So this all sounds awesome, but how realistic is it? I wanted to find out, so I started coding. My goal was to build the simplest possible mesh. Not for a hospital, of course, that would go way beyond the scope of this video, but for a doctor's office, and specifically for a dermatology practice. The idea is to personalize the appointment length to how long a patient will actually need. And we'll do that by triaging the patient before he or she makes the appointment. For that, we need 2 specialized AI agents, each with their own memories and tool use. The first agent is an assistant that makes appointments and has access to an email sending tool. And the second agent is a dermatologist that triages the patient and has access to a machine learning classifier that can detect, for example, whether a mole is cancerous. So let's see how it goes. So the code is done. Let me give you a quick run through. The brain of our models will be ChatGPT, so we call the OpenAI API here, and we'll be using an image classifier by Hugging Face. So these are the system prompts that are very important. And here we actually don't give the models too many instructions, and most of the things they decide for themselves. This is how we call define functions for the OpenAI API. And very important is the transfer function, which allows models to hand off the conversation to a different agent. So here is where we actually define our agents as functions, and you can see they can call functions themselves, the email functions and the transfer functions. So for a simple UI, we'll be using Streamlit, which is really cool. And then we just put it all together, make sure the chat history works, and let's see how it goes. All right, let's try it out. So let's ask him for an appointment.
Hello, I can assist you with scheduling an appointment. Could you please provide me with your name and contact information?
Yes, we can.
Thank you, Bossy. To determine the type of appointment you need, I will transfer you to our dermatologist AI agent to check your skin symptoms. Is that okay?
Yes, that is all right.
Hello, Bossy. I specialize in dermatology. Could you please describe your skin symptoms? If possible, it would be helpful if you can send a photo of the affected area.
I think I might have skin cancer. Let's send him a photo.
Thank you for sharing your concerns, Bossy. Based on the information provided, there is a possibility that this could be basal cell carcinoma, which is a type of skin cancer. I strongly recommend scheduling a 30-minute appointment with a dermatologist for a thorough examination and appropriate care. If it's okay with you, I will transfer you to the assistant to finalize your appointment booking.
Yes, please do that.
Thank you for your patience, Bossy. The next available appointment is on Thursday, 8/5/2025 at 11 a.m. Would you like to confirm this appointment?
Yes.
Please confirm your appointment details. Name, Bosse Rushman.
So you just saw a live demo of a multi-agent system for healthcare, where the agents handed off the conversation to each other and used tools to complete tasks. The assistant sent an email, which took a bit longer, so it's not in the demo. And the dermatologist actually accessed an advanced image classifier. And that's it for the video. I hope you now have a better understanding of how the value of AI is unlocked through connection and how LLM-based multiple agent systems for healthcare enable this value. As you can see, the exciting future for healthcare and specifically hospitals is now. And I hope that we will all contribute to it. Thank you for watching.